Hello, in this lecture we will find the value of x in two different methods. In the drawing we have quadrilateral SRPQ. We know that side SP is equal to side SQ. We also know that angle SRP equals to 65 units, angle PRQ, this angle, equals to 50 units, and we want to find out the size of angle X, or the size of angle PSQ that equals to X. Okay, so we'll start with the first method. We will do a construction. Actually, we will extend side QR and then we will draw a perpendicular to the extended QR from point S. So this angle will be equal to 90 degrees, and we will define the touching point between the perpendicular to the extended QR as capital N. Then we will draw another perpendicular from point S to PR. So actually this angle equals to 90 degrees, and we will define the touching point between the perpendicular to side PR as point M, and we will focus on the right triangles S and Q. And the right triangle SMP. This right triangle SMP. Actually, we will prove that those two right triangles perpendicular to each other. Okay, so first of all, it is given us in the question that PS equals to SQ. PS equals to SQ. And actually we extended QR by a straight line, so actually QN is a straight line. Therefore, we know the rule that states that the sum of the angles on a straight line equals to 180 degrees. Therefore, the sum of the angles on the straight line QN at point R must be equal to 180 degrees. So if we define this angle as angle Y, then we will get that at point R 50 degrees plus 65 degrees plus the size of angle y must be equal to 180 degrees. According to the rule that states that the sum of the angles on a straight line must be equal to 180 degrees. Here we will subtract 50 degrees from this equality and we will get that 65 degrees plus y equals to 180 degrees. We will subtract 65 degrees from this equality and we will get that angle y equals to 130 degrees minus 65 degrees is 65 degrees. So we actually found out that angle y equals to 65 degrees. So we can write here that angle y equals to 65 degrees. Okay? So actually we know that angle NRS, this angle, equals to angle MRS, and both angles are equal to 65 degrees. We also know that this is a right angle and this is also a right angle. So those two angles are equal to each other, they are both right angles. So angle PMS equals to angle QNS equals to angle RNS equals to this angle. Actually angle RMS, this angle, actually we will focus on triangles S and R, this right triangle and triangle SMR. This small right triangle. On here we have, so we will focus on triangles SNR and SMR. We will focus on the green triangle, triangle SMR, on the green right triangle, triangle SMR, and on the blue small right triangle, triangle SNR. And we will prove that the green triangles can go into the blue triangle, SMR, and triangle SMR and triangle SNR. Okay, so here we have side SR, that is a common side, it belongs to both triangles. So SR equals to XR, it is a common side. So side SR equals to side SR. It is a common side, it belongs to both triangles. We also know that those two angles are equal to each other. They are both equal to 65 degrees. So we can write that angle MRS, this angle, equals to angle SRN, this angle, and both those angles are equal to 65 degrees. So angle MRS equals to angle SRN, and both those angles are equal to 65 degrees. And those angles are right angles, they are equal to each other, so angle SMR equals to angle SNR, this angle, and both those angles are equal to 90 degrees. Okay, so angle SMR is equal to angle SNR, and both those angles are equal to 90 degrees. And those two angles are also equal to each other. Angle MSR, or angle MSR, this angle is equal to angle NSR, and both those so those two angles are equal to each other according to third angle theorem. Again, those two angles are equal to each other according to third angle theorem. So angle MSR equals to angle NSR according to the third angle theorem. So what is third angle theorem? Third angle theorem states that if you have two angles in one triangle that are equal to two angles in another triangle, then the third pair of angles must be also equal to each other in both triangles. Actually, we can even calculate the value of the third angle, because here we know that the sum of the angles in any triangle must be equal to 180 degrees. Therefore, this angle is 65 degrees and this angle is 90 degrees. 65 degrees plus 90 degrees is 155 degrees. So we have 155 degrees in those two angles, and this angle must complete the sum of the three angles to 180 degrees. Therefore, it must be equal to 25 degrees. Okay, so this angle equals to 25 degrees, and those two angles are also the same angle, 65 degrees and 90 degrees. And so in order to complete the sum of the angles in the right triangle SNR to 180 degrees, it must be equal to 25 degrees, because of the fact that 155 degrees plus 25 degrees equals to 180 degrees. Okay, so we can write down that angle MSR equals to angle NSR, and they are both equals to 25 degrees. Okay, so we have the third angle theorem that states that if you have two angles in one triangle that correspondingly equals to two angles of another triangle, then the third angle must be also equal, the third pair of angles must be also equal in both triangles, but we actually can even calculate the size of the third angle in both triangles, and the size of those two angles and the third angle in both triangles will be equal to 25 degrees. So we actually found out that the three angles of triangle SMR are correspondingly equal to the three angles of triangle SNR. Okay? So actually we proved that triangle SMR equals is congruent to triangle SNR according to angle side angle rule. I'll write it down. So we actually proved that triangle SMR is congruent to triangle SNR according to angle side angle rule. Okay? So what is angle side angle rule? Angle side angle rule states that if you prove that two sides and the angle between them in one triangle are equal to two sides and the angle that is between them on the other triangle, then you actually proved that those two triangles can go into each other according to angle side angle rule. Okay, so the green triangle can go into the blue triangle. Okay, so therefore side SM of triangle SMR will be equal to side SN of triangle SNR. SM equals to SN. So we can conclude from the fact that the green triangle can go to the blue triangle that SM equals to SN according to the rule that corresponding sides in congruent triangles are equal to each other. Actually, we know that the green triangle is congruent to the blue triangle. Therefore, the two corresponding sides, that is to say SM and SN, will be also equal to each other. Okay? So, in the next step, we will focus on two other triangles. We will focus on triangles, the right triangle, triangle SMP, and the right triangle, triangle SNQ. And we will prove that those two triangles can go into each other. Okay, so actually we will prove that this triangle, triangle SMP, is congruent to the right to triangle SNQ, to the right triangle, triangle SNQ. So we'll prove that the right triangle, triangle SMP, can go into the right triangle, triangle SNQ. Okay, so first of all, we have already proved that SM equals to SN. Those two sides are equal to each other. SM equals to SN. Okay, we have already proved that SM equals to SN. And we also know, according to what is given us in the question, that SP equals to SQ. SP equals to SQ. Okay, SP equals to SQ, so actually we can define SQ as Y, and then SP will be also equal to Y. That is according to our definition. And the third side PM equals to side NQ. PM equals to NQ. So side PM of triangle PMS equals to side NQ of triangle NSQ. Okay, side PM of triangle PSM equals to side NQ of triangle SNQ. So I will prove that side PM equals to side NQ. So what is the value of PM? You should remember that triangle PSM is a right triangle. This angle equals to 90 degrees. Therefore, it is a right triangle. And we know, according to the Pythagoras theorem, that PM will be equal to the root of SP square minus SM square. Okay, PM, again, PM equals to the square root of PS minus the square root of SM. Again, PM equals to the root of SP square minus SM square. Okay, what is the size of NQ? What is the size of what is the size of the perpendicular NQ according to the Pythagoras theorem? According to the Pythagoras theorem, that says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, NQ will be equal to the root of SQ square, that is the hypotenuse squared. SQ is the hypotenuse, so it is SQ square minus SN square. So NQ equals to the root of SQ square minus SN square. Okay, that is the value of NQ. But we have already found out, actually it is given us in the question that SP equals to SQ. SP equals to SQ. So those two expressions are equal to each other. SP equals to SQ. Okay, we know that SP equals to SQ. And we also know that SM equals to SN. SM equals to SN. Okay, so we found out that SP equals to SQ and SM equals to SN. Therefore, those two expressions are equal to each other. Okay? Those two expressions are equal to each other. Therefore, PM equals to QN, or PM equals to NQ. Okay? Therefore, PM equals to NQ. So we actually found out that three sides of triangle SMP are equal to three sides of triangle SNQ. Therefore, triangle SMP congruent to triangle SNQ according to side rule. So I write it down. So we can write down that triangle SMP congruent to triangle SNQ according to side rule. So what is side rule? Side rule states that if you prove that three sides of one triangle are correspondingly equal to three sides of another triangle, then you actually prove that those two triangles can go into each other according to side rule. Okay? And from the fact that triangle SMP congruent to triangle SNQ, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. We proved that the right triangle SMP is congruent to the right triangle SNQ. Therefore, those two corresponding angles will be also equal to each other. So, we can write down that angle MQR is equal to angle MPS, this angle. Okay, from the fact that triangle SMP is congruent to triangle SNQ, we can conclude that those two angles are equal to each other. That angle MQR equals to angle MPS. And if we define one angle as theta, then the other angle will be also equal to theta. Okay, so here we write down that those two angles are both equal to theta. Okay, so actually we have another rule that states that if I write it down, the rule states that rule number 1 states that if two equal angles subtend on the same line segment from the same side, if two equal angles subtends on a line segment from the same side, then the 4 points lie on a circle. So I read rule number 1 again. Rule number 1 states that if two equal angles subtends on a line segment from the same side, then the 4 points lie on a circle. So here we can actually implement rule number 1 in our drawing, because here we have two equal angles. They are both, those two angles are both equal to theta, and they are both subtend on the same line segment SR. Angle RQS subtend on line segment SR, and angle SPR, this angle, subtend on the same line segment SR. Therefore, according to rule number 1, the 4 points, that is to say S, R, P and Q, lie on a circle. That is to say, you can actually draw a circle around the quadrilateral SRPQ, and points S, R, P and Q will be on the circle. Okay, so we will draw a circle and we will put those 2 points S, R, P and Q on that circle. Okay, so we have a circle So actually, according to rule number 1, because of the fact that those two equal angles that are both equal to theta subtend on the same line segment, that is to say they both subtend on the line segment SR, then according to rule number 1, those two 4 points S, R, P and Q lie on a circle. As you can see, those 4 points P, S, R and Q, they all lie on this circle. Okay, that is according to rule number 1, because of the fact that those two equal angles subtend on the same line segment SR, then you can put those 4 points S, R, Q and R, S, R, Q and P on a circle. Okay? Those two 4 points lie on a circle that inscribes this quadrilateral. Okay? So that is the implementation of rule number 1 in our drawing. We can put those 4 points on a circle. Okay? So in this drawing you can see that angle X subtend on chord PQ, and this angle that equals to 50 degrees subtend on the same chord PQ. And we have a rule that states that rule number 2, rule number 2 states that peripheral angles that subtend on the same chord are equal to each other. So I will read rule number 2 again. Rule number 2 states that peripheral angles that subtend on the same chord are equal to each other. So actually, as I've already explained, those two peripheral angles X and 50 degrees, they are both subtend on the chord PQ. Therefore, according to rule number 2, they are equal to each other. That is to say, X equals to 50 degrees. X equals to 50 degrees according to rule number 2. Okay? So we actually found out that X equals to 50 degrees according to rule number 2. Okay? So in the next step, I will present to you a second method to find out the value of x. Okay? So actually in this method, in the second method, we will extend line segment SR and then we will draw a perpendicular from point Q to the extended line segment SR. So this angle is a right angle because we draw a perpendicular to the extended SR, extended line segment SR. We will define the touching point between the perpendicular to the extended line segment SR as point M, and then we will extend QM in such a way that Q dash M will be equal to QM. So Q dash M equals to QM according to our construction. Actually, I don't have enough place in the page, so I will draw again the drawing. So we have here PQ, So here we actually extended QM until point Q dash in such a way that QM equals to Q dash. Okay, QM equals to Q dash M. Again, QM equals to Q dash M. QM equals to Q dash M. According to our construction, then we will join points R and Q dash together by a straight line. Again, we join together points R and Q dash by a straight line. I repeat again, we joined together points R and Q dash by a straight line. Then we'll join together points S and Q dash by a straight line. Again, we join together points S and Q dash by a straight line. Actually, we drew perpendicular from point Q to point M, so this angle equals to 90 degrees because it is a perpendicular to point M. And we know that Q dash is a straight line because we extended the straight line QM, the perpendicular QM by a straight line, so Q dash, the segment line Q dash is a straight line. And we also know that the sum of the angles along the straight line is equals to 180 degrees at any point. So at point M, the sum of the angles on the straight line Q dash equals to 180 degrees. Therefore, we can write down that that 90 at point, if we focus at point M, we will write down that 90 degrees plus the size of this angle that we'll define it as Y equals to 180 degrees. Okay, according to the rule that the sum of the angles on a straight line equals to 180 degrees. So at point M, the sum of the angles along the straight line Q dash equals to 180 degrees. That is to say 90 degrees plus the size of angle Y equals to 180 degrees. Here we will subtract from this equality 90 degrees, and we will get that angle Y equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle Y is a right angle. It equals to 90 degrees. So we can write here that angle Y is a right angle, that is to say it equals to 90 degrees. So in the next step we will focus on the right triangle QMR. And the right triangle QDSMR. Actually, we will prove that those two right triangles can go into each other. Okay. First of all, we know that QM equals to QDSM according to our construction. QM equals to QDSM. That is according to our construction. Again, in those two right triangles, we know that QM equals to QDSM. We also know that those two angles are equal to each other. They are both right angles. That is to say, angle QMR, this angle, is equal to angle QDSMR, this angle, and they are both equal to 90 degrees. Okay, angle QMR equals to angle QDSMR, and they are both equal to 90 degrees. They are both right angles. And RM is a common side. That is to say, RM equals to RM. It's a common side. It belongs to both triangles. RM equals to RM. It's a common side. Again, RM equals to RM. It is a common side. It belongs to both triangles. So we actually proved that the right triangle QMR is congruent to the right triangle QDSMR according to side angle side rule. So I write it down. We proved that the right triangle QMR is congruent, that is the sign of congruent, to triangle QDSMR according to side angle side rule. Okay, so those two triangles can go into each other according to side angle side rule. So what is side angle side rule? Actually, if you prove that two sides and the angle between them of one triangle are correspondingly equal to two sides and the angle between them on the other triangle, you actually proved that those two triangles can go into each other according to side angle side rule. Okay, so in the next step we will focus on two other right triangles. We will focus on triangle, the big right triangle QMS, this triangle, so before that, after we proved that those two triangles can go into each other, we can conclude some things, but before that, here we extended SR, so SM is a straight line, and we know that the sum of the angles on a straight line at any point is equal to 180 degrees. Therefore, at point R, the sum of the angles must be equal to 180 degrees. Here we have 65 degrees, and 50 degrees is 115 degrees. And in order to complete the sum of the angles at point R to 180 degrees, this angle must be equal to 65 degrees. Okay? And we actually have already proved that the right triangle QRM is congruent to the right triangle QDES-MR. Those two right triangles can go into each other. Therefore, we can conclude from the fact that those two right triangles can go into each other that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if this angle equals to 65 degrees, then this angle will be also equal to 65 degrees. Okay? And from the fact that those two triangles can go into each other, you can conclude that QR equals to QDES-R. QR equals to QDES-R. So those two sides are equal to each other according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles, those two right triangles can go into each other, therefore those two corresponding sides will be also equal to each other. Okay? So, in the next step, we will focus on the two right triangles, two bigger right triangles. We will focus on triangle, the big right triangle, triangle QMS, and triangle QDES-MS, the right triangle QDES-MS, and we will prove that those two big right triangles can go into each other. Actually, we know that QM equals to QDES-M according to our construction. QM equals to QDES-M according to our construction. Okay, QM equals to QDES-M according to our construction. We also know that those two angles are also equal to each other. They are both right angles. So angle QMS, this angle, is equal to angle, this angle Q decimal MS, and they are both equal to 90 degrees. Okay, angle QMS equals to angle Q decimal S, and they are both equal to 90 degrees. They are both right angles. And also SM is a common side. It belongs to both triangles, so we can write down that SM equals to SM is a common side. SM equals to SM. It is a common side. Okay, so SM equals to SM. So we actually proved that the triangle QMS, the big right triangle, is congruent to the big right triangle Q decimal S according to side angle side rule. Okay, so I write it down. We proved that triangle QMS is congruent to triangle Q decimal S. Okay, triangle QMS congruent to triangle Q decimal S according to side angle side rule. I've already explained to you what is side angle side rule. If you prove that two sides and the angle between them in one triangle correspondingly equal to two sides and the angle between them in another triangle, then you actually proved that those two triangles can run to each other according to side angle side rule. So from the fact that those two big right triangles can go into each other, we can conclude that QS equals to Q decimal. Okay, we can conclude that QS equals to Q decimal S. QS equals to Q decimal S. And if we define QS as Y, here PS also equals to QS, so SP also will be equal to Y, and we prove that SQ equals to Q des S, so Q des S will be also equal to Y. Okay, so in the next step, we'll focus on triangles SRQ and triangle SRQ des. Those two triangles so on those two triangles so I will actually paint it in order to make it clear. We'll focus on the green triangle QRS, and on the blue triangle QDS-RS. So on the green triangle and the blue triangle, we know that QR, this side, is equal to Q dash R. This side, those two sides are equal to each other. QR is equal to Q dash R. We have already proved that those two sides are equal to each other. So QR equals to Q dash R. So, and we also proved that QS is equal to Q dash S, and they are both equal to Y. QS is equal to Q dash S, and they are both equal to Y. Okay, and SR is a common side, it belongs to both triangles, so SR equals to SR. It's a common side. Okay, SR equals to SR. It is a common side, it belongs to both triangles. So we actually proved that the triangle SRQ is congruent to triangle SRQ dash according to side rule. So I write it down. Triangle SRQ is congruent. Triangle SRQ is congruent to triangle SRQ dash according to side rule. So what is side rule? Side rule is if you prove that three sides of one triangle correspondingly equal to three sides of another triangle, then you actually prove that those two triangles can relate to each other according to side rule. Okay? And from the fact that the green triangle can go into the blue triangle, we can conclude that those two angles are equal to each other. Okay, angle RQS is equal to angle RQ-S. Okay, I'll write it down. Of the fact that triangle SRQ is congruent to triangle SRQ-, we can conclude that angle RQS, this angle, is equal to angle RQ-S, this angle. And if we define angle RQS as theta, then angle RQ-S will be also equal to theta, because they are equal to each other. Okay? So we found out that angle RQS is equal to angle RQDS, and they are both equal to theta. Okay? So in the next step, we will prove that line segment PQDS is a straight line. Okay, again, we will prove that line segment PQDS is a straight line. Okay. First of all, what is PR? PR is a diagonal in quadrilateral SRPQ. So PR as a diagonal in quadrilateral SRPQ must be a straight line, okay? So PR is a straight line as diagonal in quadrilateral SRPQ. PR is a straight line. Okay, so PR is a straight line as diagonal in quadrilateral SRPQ. And we also know that RQDS is a side in a triangle, the right triangle RQDS-M. Therefore, it is a straight line. So I read it again. RQDS is a side in triangle RQDS-M, therefore it is a straight line. So when we join together those two straight lines, the straight line PR and QDS-R, the only question that is left to answer whether if PQDS is a straight line is what is happening at point R. If at point R we have 180 degrees, then we can conclude that PQDS is a straight line, because RQDS is a straight line and PR is also a straight line. And when you join together those two straight lines, you also get a straight line, because if the sum of the angles at point R is equal to 180 degrees, then you know that here we have a straight line. Around R we have a straight, around point R we have a straight line, therefore the line segment PQDS must be a straight line. So which angles we have at point R? At point R, on one side actually, only in one side, we will check which angles we have at point R. On this side of point R, we will check which angles we have. So at point R we have angles that are equal to 50 degrees plus 65 degrees plus 65 degrees. Okay, so in total at point R, at one side of this side of point R, we have 50 degrees plus 65 degrees plus 65 degrees. So, and 65 degrees plus 65 degrees is 130 degrees. 130 degrees plus 50 degrees is 180 degrees. So we actually found out that at point R, in one side of at point R, we have 180 degrees. Therefore, we can conclude that PQ dash is a straight line. Okay, we can conclude from it that PQ dash is a straight line. Okay, because what is actually angle that equals to 180 degrees? Any angle that equals to 180 degrees is a straight line. That is the definition of angle that equals to 180 degrees. Angle that equals to 180 degrees, it is actually a straight line. So here we have a straight line. Therefore, line segment PQ dash is a straight line. So from the fact that line segment PQ dash is a straight line, we can conclude that the structure PSQ dash is a triangle. Okay, so PSQ dash is a triangle. Okay, from the fact that PQ dash is a straight line, we can conclude that the structure PSQ dash is a straight line. Okay, the structure PSQ dash is a triangle. Okay, and in triangle PSQ dash, we know that PS equals to SQ dash. Okay, in triangle PSQ dash, we know that PS equals to SQ dash. And we have the rule that states that in front of equal sides in a triangle, there are equal angles. Okay? In front of equal sides in a triangle, there are equal angles. So, in front of this angle theta, we have side PS, and in front of this angle, we have this side that is also equal to y. Therefore, those two angles must be equal to each other because they are located in front of equal sides, therefore they are also equal to each other. So if this angle is theta, then this angle also must be equal to theta. Okay? So here I'll continue exactly like I did in the first method. We have here two angles that are both equal to theta, and they subtend on the line segment SR. Therefore, according to the rule that I already stated, if you have two equal angles that subtend on the same line segment, that is to say on SR, then you actually can put those 4 points, or those 4 points S, R, Q, and P lie on a circle. Okay? Because of the fact that those two angles lie on the segment line, on the same segment line SR, you can actually, those 4 points Q, P, S, and R lie on a circle. So actually we can draw a circle around points S, R, Q, and P, and those 4 points will be on that circle. Okay, so I will draw it again. So I will repeat again on rule number 1. Rule number 1 states that if you have two equal angles, those two equal angles that lie on the same segment line SR, then you can put those 4 points S and R and P and Q, they lie on a circle. Okay, as you can see here, those 4 points S, R, P, and Q lie on this circle. Okay, that is true according to rule number 1. And as you can see from the drawing, we have here two peripheral angles, peripheral angle X and this peripheral angle that equals to 50 degrees, and they subtend on the same chord PQ. Angle X subtends on chord PQ, and this angle that equals to 50 degrees subtend on the same chord PQ. Therefore, according to rule number 2, they are equal to each other. That is to say, angle X equals to 90 degrees. Angle X equals to 90 degrees. Again, according to the rule number 2, that states that peripheral angles that subtend on the same chord are equal to each other. those two peripheral angles x and 50 degrees subtend on the same chord PQ, therefore they are equal to each other. That is to say, angle x equals to 50 degrees. So we found out that angle x equals to 50 degrees according to the second method also. So now I will summarize the lecture. We actually wanted to find out the value of the size of angle x. We wanted to find out the value of angle PS and PSQ, this angle x. We have this angle PRQ that equals to 50 degrees. This angle SRP equals to 50 degrees. And we want to find out the value of this angle x. Okay. So the first thing that we did is we did a construction. We extended side QR by a straight line, and then from point S we drew perpendicular to the extended QR. We define this point as point N, so angle SNR is a right angle because this is the perpendicular to QR, to the extended QR, so this angle equals to 90 degrees. And then in the next step, from point S, we drew perpendicular to side PR. So the touching point between the perpendicular to PR is at point M. So this is a perpendicular, therefore this angle equals to 90 degrees. Then we focus on the green right triangle and on the blue right triangle, and we actually proved that the green triangles can go into the right triangle. Why? Because we have SR is a common side, it belongs to both triangles. So SR equals to SR, and we have those two angles that are equal to each other. We found out that those two angles are both equal to 65 degrees, and we also those two angles are also equal to each other. They are equal to 90 degrees according to our construction. And so we have in the green triangle and also in the blue triangle, we have one angle that equals to 65 degrees and the other angle equals to 90 degrees. So 65 degrees plus 90 degrees is 155 degrees. And we know that the sum of the angles in any triangle must be must be equal to 180 degrees, and we have 155 degrees that is the sum of two angles in the green triangle and also in the blue triangle. So the third angle must be equal to 25 degrees in both triangles in order to complete the sum of the angles in any triangle to 180 degrees. Because 155 degrees plus 25 degrees is 155 degrees plus 25 degrees is 180 degrees. So the third angle must be also equal to 25 degrees in both triangles. So the third angle also equal to each other in both triangles, and it equals to 25 degrees. So we actually proved that all these angles in the green triangle are equal to the corresponding angles in the blue triangle, and we also have a common side that is equal to, so this common side belongs to both triangles, so you can write down that SR equals to SR, and we have three angles in the green triangle that correspondingly equal to three angles on the blue triangle. Therefore, we actually proved that the blue triangle is congruent to the green triangle according to side angle rule. Okay? Triangle SMR is congruent to triangle SRQ according to side angle rule. So what is side angle rule? If you prove that two sides and the angle between them of one triangle is correspondingly equal to two sides and the angle between them on another triangle, then you actually proved that those two triangles can go into each other according to side angle rule. Okay? From the fact that the blue triangle can go into the green triangle, we can conclude that those two sides are equal to each other, that is to say SM equals to SN. SM equals to SN according to the rule that corresponding sides in congruent triangles are equal to each other. The green triangle corresponding to the green triangle congruent to the blue triangle, therefore those two corresponding sides SM and SN will be also equal to each other. So SM equals to SN, and then we focused on two other right triangles. We focused on the right triangle SMP, this right triangle, and we also focused on the right triangle SNQ. So on those two right triangles, we know that we've already proved that SM equals to SN. We also know it is given us in the question that SP equals to SQ, and we proved that PM equals to NQ. Why PM equals to NQ? Because what is the value of PM? We know that triangle PMS is a right triangle. Therefore, we can implement the Pythagoras theorem in the right triangle PMS. So PM, according to the Pythagoras theorem, equals to the root of SP square minus SM square. Okay? PM equals to SP square minus SM square. Okay? And what is the value of QN? We should remember that SNQ is a right triangle. Therefore, we can implement the Pythagoras theorem in the right triangle SNQ. So the value of NQ will be equal to SQ to the root of SQ square minus NS square. Okay? the value of NQ according to the Pythagoras theorem equals to SQ to the root of SQ square minus SN square. Okay, but we know that SP equals to SQ, SP equals to SQ, and SM equals to SN. SM equals to SN. So those two expressions are equal to each other. Those two expressions are equal to each other. Therefore, PM equals to NQ. Okay, we actually proved that the third angle on those triangles are also equal to each other in both triangles. Therefore, we actually proved that triangle SMP, the right triangle SMP, this right triangle is congruent to the right triangle QMR. The right triangle SMP is congruent to the right triangle SNQ. Again, the right triangle SMP, this right triangle SPSN, PSM is congruent to the right triangle SNQ. So this right triangle SNQ, according to the rule that side rule. Okay. So from the fact that this right triangle is congruent to this right triangle, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other. Therefore, those two corresponding angles will be also equal to each other. So if one angle, this angle is theta, then this angle will be also equal to theta because of the fact that they are equal to each other. Okay, so we can write down that angle MQR equals to angle MPS. They are both equal to theta. Okay. Then we have rule number 2 that states that if two equal angles subtend on a line segment, on the same line segment from the same side, then the 4 points lie on a circle. So we actually can implement rule number 1 in our drawing, because here we have two angles that are equal to each other. They are both equal to theta. That both those two angles subtend on line segment SR. Therefore, according to rule number 1, the points S, R, P, and Q lie on a circle that inscribes this quadrilateral. Okay? So according to rule number 1, points S, R, P, and Q lie on a circle that inscribes this quadrilateral. So we can draw a circle, and according to rule number 1, those 4 points S, R, P, and Q lie on this circle. As you can see, those 4 points lie on this circle that I drew. That is according to rule number 1, because of the fact that those two angles that are equal between them lie, subtend on the same segment line SR, then those 4 points S, R, P, and Q lie on this circle. Okay? That is the implementation of rule number 1 in our drawing. Okay? So here we have a circle, and in this circle we have two peripheral angles. Peripheral angle X subtend on chord PQ and peripheral angle PBQ that equals to 50 degrees subtend on the same chord PQ. Therefore, according to rule number 2, that states that peripheral angles that subtend on the same chord are equal to each other, angle X will be equal to 50 degrees. Again, we have rule number 2 that states that peripheral angles that subtend on the same chord are equal to each other. We have angle X that subtend on chord PQ, and we have this angle PBQ that equals to 50 degrees subtend on the same chord PQ. Therefore, those two angles that subtend on the same chord will be equal to each other. That is to say, angle X will be equal to 50 degrees. Okay, so that was the first method to find out the value of X, and we found out that the value of X is actually 50 degrees, or the size of angle X is equal to 50 degrees. And then we actually found out the value of X according to a second method. In the second method, we actually did another construction. We actually extended side SR, we extended side SR until point M, and then from point Q we drew perpendicular to point M, or perpendicular to the extended line segment SR. So this angle equals to 90 degrees according to our construction, because QM is perpendicular to extended SR, so this angle equals to 90 degrees. Then we extended QM in such a way that Q dash M will be equal to QM. Again, Q dash M equals to QM according to our construction. Okay, so those two sides are equal to each other according to our construction. And then from point R, we connected points R and Q dash by a straight line. And then we also connected or joined together points S and Q dash by a straight line. And then we actually, in order to find out the value of this angle, we use the rule that states that, first of all, we know that Q dash is a straight line because we extended QM by a straight line. Therefore, Q dash is a straight line. And we know that the sum of the angles on any point along a straight line equals to 180 degrees. Therefore, at point M on the straight line Q dash, the sum of the angles must be equal to 180 degrees. On one side of point M, the sum of the angles must be equal to 180 degrees. So which angles we have at point M? We have here 90 degrees plus this angle that is Y, according to our definition, must be equal to 180 degrees. So 90 degrees plus the size of angle Y equals to 180 degrees. Here we subtracted 90 degrees from this equality, and we got that angle Y equals to 90 degrees. So we found out that this is a right angle. Then we focused on those two right triangles, on triangle QMR and on the right triangle Q dash MR, and we actually proved that those two right triangles can go into each other. First of all, we know that QM equals to Q dash M according to our construction. Then we know that those two angles are equal to each other and they are both equal to 90 degrees. We have already proved that this angle equals to 90 degrees and this is perpendicular from point Q, therefore it equals to 90 degrees. So those two angles are equal to each other and they are both equal to 90 degrees. So angle QMR equals to angle Q dash MR and they are both equal to 90 degrees. And RM is the common side, it belongs to both triangles, so RM equals to RM. So we actually proved that triangle QMR can go into triangle Q dash MR according to side angle side rule. So if you prove that two sides and the angle between them of one triangle are correspondingly equal to two sides and the angle between them on the other triangle, you actually proved that those two triangles can go into each other according to side angle side rule, okay? From the fact that those two triangles can go into each other, we can conclude that QR equals to Q dash R. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding sides will be also equal to each other. Therefore, QR equals to Q dash R. Then we focused on the big right triangles, on the big triangle QMS and on the big triangle Q dash, on the big right triangle Q dash MS. So we proved that those two big right triangles can go into each other. First of all, we know that QM equals to Q dash M according to our construction. Then we know that those two angles are equal to each other, they are both equal to 90 degrees. And we have a common side, this side SM, it belongs to both triangles. Therefore, SM equals to SM as a common side. Actually, we proved that triangle QMS, this right triangle, is congruent to triangle Q dash MS according to side angle side rule. We proved that those two sides, this and this angle, are corresponding equals to those two sides and this angle. Therefore, we proved that those two triangles can go into each other according to side angle side rule. From the fact that those two triangles can go into each other, those two big right triangles can go into each other, we can conclude that side QS of triangle QMSM is equal to side Q dash S of triangle Q dash MS. So this side is equal to this side. Okay, QS equal to Q dash S according to the rule that corresponding sides in congruent triangles are equal to each other. Okay, so those two sides are equal to each other, and actually if one side is equal to y, then the other side will be also equal to y, and we know that those two sides are also equal to each other. It is given us in the question, so if this side is equal to y, then this side will be also equal to y. Okay, in the next step we will focus on the green triangle and the blue triangle, and we actually proved that the green triangle is congruent to the blue triangle. And how? Actually, we know that QR is equal to Q dash R. We have already proved that those two sides are equal to each other, and we also proved that QS is equal to Q dash S. They are both equal to Y, and we have a common side. SR belongs to both triangles, both to the green triangle and to the blue triangle. So SR is equal to SR according because it belongs to both triangles, so it is a common side. So we actually proved that the green triangle is congruent to the blue triangle according to side rule. Okay, the green triangle SRQ is congruent to the blue triangle SRQ dash according to side rule. From the fact that the green triangle is congruent to the blue triangle, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Actually, the green triangle is congruent to the blue triangle, therefore those two corresponding angles will be equal to each other. So if one angle is theta, then the other angle will be also equal to theta. Okay? Then we actually proved that line segment PQ dash is a straight line. How? First of all, we know that PR is a diagonal of quadrilateral SRPQ. Therefore, it must be a straight line. And we also know that Q dash R is a straight line because it is one side of triangle Q dash RM. Therefore, it must be also a straight line. So we have two straight lines that are connected together, and they actually touch each other at point R. So if the sum of the angles at point R will be equal to 180 degrees, then we can conclude that PQ dash is a straight line. So what is the sum of the angles at one side at point R? It is actually 50 degrees plus 65 degrees plus 65 degrees. And 50 degrees plus 65 degrees plus 65 degrees equals to 180 degrees. Therefore, here at point R we have straight line because angle that equals to 180 degrees, it is actually a straight line. So from that fact we can conclude that actually PQ dash is a straight line. And because of the fact that PQ dash is a straight line, we can conclude that the structure SPQ dash is a triangle. So we can conclude that the structure SPQ dash is a triangle, and then in triangle SPQ dash we have two sides that are equal to each other, that is to say SQ dash is equal to PS, and they are both sides equals to Y. And we have the rule that states that in front of equal sides in the triangle there are equal angles. So those two angles are located between those two equal sides, therefore they will be equal to each other, and we know that this angle is theta, so this angle must be also equal to theta because those two angles are equal to each other. So here we have two angles that subtend on the same line segment SR. Therefore, according to rule number 1, those 4 points P, Q, S, and R lie on a circle. Okay, according to rule number 1, those 2 points S, R, P, and Q lie on this circle. So here we have two peripheral angles. Angle X is a peripheral angle, and this angle PRQ that equals to 50 degrees is also a peripheral angle, and those two peripheral angles subtend on the same chord, that is to say they both subtend on chord PQ. Therefore, according to rule number 2, they are equal to each other because rule number 2 states that peripheral angles that subtend on the same chord equal to each other. Therefore, those two peripheral angles, x and 50 degrees, that subtend on the same chord PQ will be equal to each other. That is to say, angle x equals to 50 degrees. Okay, that is the answer to the question according to the second method. Okay, thank you very much.